Welcome all. Really excited to invite you to this event today, put on by Aurora Digital, TLA Smart Cities, and Tech UK. Really grateful for their support for this event. As I'm sure you saw when you registered, we've got a stellar lineup of speakers for you today, who hopefully will be able to provide you with a really good understanding of the capabilities with 5G, particularly around sort of video analytics and computer vision. Hopefully you learn a lot. Be great if we can be interactive. Please ask any questions as we go through. I believe there's going to be a poll at some stage during the event as well, so please participate in that. You've got a very, very senior level of speakers today, so hopefully that's an opportunity for you to ask anything that you want. Just as a background, Aurora Digital, what we do, if you've never heard of us, is we support and showcase great tech. I mean, that's kind of what we're about, and that's why we work with people like Tech UK and TLA Smart Cities and so on. And so we run a bunch of events like this. Today, the session is moderated by the wonderful Richard Foggy from KTN, the Knowledge Transfer Network. Far more knowledgeable about this area than I am. I hope you really enjoy the event, and I would really like to hear your feedback afterwards. And with that, Richard, I will hand over to you.
Thank you, Sandy. Welcome everybody to the wonderful world of MEC. Mobile edge computing, as panelists, attendees have already picked up, it is strictly, according to EXE, multi-access edge computing. It's an example of the flexibility of architecting that 5G allows, so that you can develop solutions that are specific to the application that you're looking at. Sandeep's correct. We've got a stellar lineup, self-excluded. I'm Foggy from UK 5G, in addition to wearing a KTN hat. So moving swiftly on, Danny Kelly, could you tell us whether this MEC thingy, does it enable growth or anything? Or
it's been rumored to, Richard. Yes, I believe so. Yes, I think Richard, 5G and MEC, it poses a great opportunity for us to really transform industry. But I think if we just talk about 5G and MEC on their own, I think we miss the other key part, and that of course is the applications that take advantage of that. So the growth opportunities now is not because the network operators have built great 5G networks that bring, of course, speed and latency and security and all the great benefits of 5G. But the reality is the growth opportunities is born when we bring together 5G and MEC, as you say, and then those great applications that take advantage of those attributes across the edge compute and across the 5G networks. So when we combine all of that together, we're in a space where we can now really begin to transform industry. But the reality is, and it's very different where we are today, I think in the past, we've all went off there and built products and services and tried to sell them to customers and took them on a journey of transformation. Today, 5G and MEC and applications really requires an ecosystem of partners to do that. We don't know one supplier has all of the answers, and therefore we've got to work together with our customers to understand what outcome are we trying to achieve, and then work backwards from that outcome. When we understand the transformational outcome, we can understand, okay, so what's the network configuration for that? What's the edge compute configuration for that, or the MEC configuration? And what's that secret sauce? What is the application that really brings that to life? So when we bring together this triage of applications, edge compute, and 5G networks, we really unlock the true potential of 5G.
Indeedy, and I'm given to understand that the thing with 5G and particularly with MEC is the massive volumes of data that can be shuffled around, cut, sliced, discarded, so you keep the good stuff. And the sort of devices that we're looking at, UHD video. Is it typically those very heavy bandwidth applications? Is that where we're going to see MEC deployed?
Yes, it's a primary use case for MEC. So that data is expensive to transport across the network. So that MEC really brings the compute part to the customer. So it's no longer about the cloud. The cloud was once king. Everything was in the cloud, but now actually the cloud's no longer king. We need to bring all of that compute that exists in the cloud right down to the customer site, or at least to the edge of the network, so that we can compilate that AI and compilate that video analytics, right at the customer site. So that's a brilliant AI and video analytics is a great use case of MEC, whereby we can take the attributes of speed and bandwidth and capacity that 5G brings, but it's only half the story. Where do we process all of that information, all of that hungry data? And it's at the edge. So this is where MEC plays its part. And of course, video analytics is a super use case for that.
Okay, so it's pulling the cloud down to ground level. I don't know, fog computing was a phrase that was bandied about. Is this fog computing made real?
Yeah, we're getting into that space, right? So I think it is only one of the use cases, of course, that we can leverage for MEC. It's a great use case, but I think every industry, when we think about what we're doing, whether it's robotics, autonomous vehicles, all of these things have a computational requirement that needs to happen close to the customer, close to the site, and close to the edge. So there's lots of use cases that we'll see all have these same attributes, which is where do we compute that information. And MEC gives us now the ability to really transform industry around, and whether it's transport, logistics, healthcare, manufacturing, you name it. We just think about, okay, what is the outcome we want to achieve, and how do we process that on the 5G network, and actually where does that data live? Is it at the edge of the network, or is it the customer site?
Thank you, sir. Indeed. And a good nod to applications there. Speaking of applications, smart cities. Now, there's an awful lot of data. There's an awful lot of people. There's an awful lot of useful stuff probably to be had if you can get that right. Paul Armstrong, can I move to you, sir? And could you give us some observations around using video and AI in a smart cities context?
Yeah, so if we think of 5G and MEC, I think the three things that lots of people talk about that it brings to a place is kind of speed and bandwidth, that latency of response, and the ability to deploy really dense deployments of applications and sensors. But I think there's also a really important part in there on the architecture of 5G actually brings together this merger of the fiber world, the Wi-Fi world, and the cellular world to make sure that everything's always connected as it moves around a city. But I think the kind of the $1 million question for everyone is always, so what? Like, what does that mean? And I suppose when we talk about what that means for a smart city, so connectivity is at the heart of everything that we do as a smart city, and our ability to crunch large volumes of data is what underpins us being a smart city. And actually MEC allows us to move from, I think, what we historically called a smart city, but if really we're honest, it was more a monitoring city. So we got really static measurements about how full a bin was, for instance, and to really a city that moves truly to smart, a city that's dynamic and responsive to the needs that are there right now. And I think that's where we're seeing a huge shift over this move towards higher fidelity sensing, more data, the use of video, and actually how we start to push some of that data back to citizens, or how we push that data back to industry around the city so that they can respond to what's happening in the city as well.
Indeed. Do you have some slides you could share with us?
I do. I've got a couple of examples of just some of the things that as a city we use edge computing for, and the types of analytics that we can do on the data. I think it's fair to say, if you asked me probably even 2 years ago, if you thought that as a city we would be doing computing on iPhones in cars as they move around the city, or on the top of a car park, it would be my worst nightmare, and I wouldn't have ever believed you that we would do those things. But I've just got a couple of examples to show that those are actually real and those are things that are happening now. So I will just share these. So the first example is a project called How Busy Is Toon? So this was funded by MHCLG, and this was all about how does a city recover, and how does a smart city recover from the COVID pandemic. So what you should be able to see there in the corner is there's a little video that we run on our CCTV, and it gives real live time information about how people are moving around the city. And we use that, so we used it in our COVID response. So the Director of Public Health could give people real time and real data backed evidence of how people were socially distancing around town, how people were returning to town. And also we use these things to publish on a website. So before anyone came into town, they could make informed choices about actually whether they wanted to come in, whether they could socially distance safe when they chose to do so. So again, that was just, we had an existing CCTV estate, but being able to compute at the edge allowed us to run other AI models across our CCTV estate that would give us huge amounts of more data than we'd ever had on the past. And the next one is a program called Detector. So this is something that we are spinning out of Newcastle University. So this is using an iPhone within vehicles that go around the city. So this is again using edge computing for video AI. It goes around and it real-time maps all of the assets in the city. So you can see there are lots of pretty dots and colors as it picks things up as it goes around. And this underpins a lot of our work around digital twins. And again, that's edge computing in the car, backed up by connectivity that allows us to back all that data off. And again, the kind of move is, in the past, this was done with probably 50 grand's worth of kit in a Google car. And actually the network is starting to allow us to do those types of things with off-the-shelf hardware now. So it's hugely cost effective, and we're starting to see lots of examples like that coming in cities. And I think that's where a lot of the examples that you'll see in cities come up. So there'll be a lot around of those dynamic use cases. So things like, how do we manage advanced logistics? How do we manage the road networks, things like that, things where we can see data and we can make changes that change the environment. And I think that's where I see the real big use cases for edge computing and 5G in cities.
Thank you kindly, sir. Indeed, it's interesting, the use of sort of COTS technology there. How easy do you think it's going to be to get the 5G infrastructure out there? Piece of cake, pulling teeth?
As with everything digital infrastructure, I think that'll depend where you are in the country. Sadly, we do find that these things are always easier to deploy in dense urban environments. I think the reality is networks cost a lot to build, and it would be very easy of me to say, well, I want connectivity everywhere and I want someone else to pay for it. I think where industry and cities and the telecoms market can work together is starting to stack up some of these business cases, so that actually in a rural environment, we're not just talking about, well, I want you to deploy 5G because it gives my residents access to employment opportunities, education opportunities, and healthcare opportunities, but also it'll underpin advanced logistics, it'll underpin future tourism and a digital offer. It will underpin how we do logistics in that place with autonomous vehicles. And kind of as we stack up all of these, I think that's when we start to really see the business case drive down that value, that kind of cost to deploy against value for some of these things right across the country.
Oh, indeed. So an aggregation of applications, but that will come up with a value proposition that justifies it.
Yeah, and I think the kind of, as we look at the technology for 5G, the move towards software orchestration so the network can be responsive to lots of different use cases and be optimized for lots of different use cases and respond to what's happening around it. I think that really suits this model of lots of tenants on a network, using it for lots of different things that have varying requirements throughout the day or throughout the month or throughout the year.
Thanks, sir. Danny, you got your hand up.
Yeah, very politely using it. And I just wanted to come in on the deployment of the 5G and the network 5G deployment. We all absolutely have a responsibility to ensure that as ubiquitous as possible and as quickly as possible. But actually in the enterprise space, 5G is truly ubiquitous today. So we can bring, of course, 5G networks to any business, to any premise, to anywhere. And there's lots of different ways we can skin a cat, Richard. It's not all about mobile private networks. It could be an in-building 5G coverage scheme, which doesn't cost the earth, but it allows true transformation. So it really just comes down to what is that application that we're attempting to enable? And then backwards from that, we can work out what is the network architecture? How do we deploy that for our customers? Now, in the public 5G space, of course, it's about how do we get that public 5G network rolled out for consumers to enjoy it, for businesses to take advantage of the public 5G, but actually to get that real security, low latency bandwidth requirement for certain applications, including video analytics, then we've got to be looking at a dedicated scheme. So how do we create that dedicated scheme? And the answer is today we can bring 5G anywhere. And that's true of all of the operators. We all have the ability to serve all of our customers across the whole country. So it's a great time to begin that transformation conversation for a right across industry. It is first and foremost an enterprise play.
Thank you. Yeah, good observation. I've got to say 5G isn't a Jan tomorrow sort of offer. You're absolutely right. There's great examples, and it doesn't have to be mass geo inside a shed doing very funky things very fast. That goes on. Yeah, indeed. Hafsa, indeed, from a Highways England perspective, now the use of video, I'd have thought is key to your operations. What are you doing with? What's the potential for 5G MEC and AI here?
Yeah, so a little bit of background on me. So I'm with KPMG, and I work with public sector on their digital data and technology strategy and transformation projects with a focus on mobility. So currently working with Highways England, as you mentioned. And we've done loads of work in the past, just looking at the economic benefit and value of connectivity. So coming at it from a mobility perspective, we've seen numbers so ranging from £50 billion to £75 billion of economic value of cabs by 2030. We also see research suggesting, traffic delays reduction of 10% by the introduction of 5G networks. So given all of that news, Highways England has been working on developing their vision for digital roads, which is essentially looking at how they can harness connectivity in all of their operations. So starting right from construction to operations and how they deliver information to customers. And connectivity and 5G and video analytics actually plays a role in all of these three pillars. Starting from construction, biggest thing on a construction site is safety. So they are looking at how they can make sure that in the next 5 to 10 years, all of the new major schemes coming up can be connected, and starting to look at how video analytics can be used to make sure that there's enhanced safety on site. Going into operations, massive implications for traffic management, starting from actually just improving how the signals are set by dynamically monitoring the flow of traffic. Going to actually, if there's an incident, being able to spot a stopped car in a live lane. So there's a lot of trials happening in that space. Going one step beyond that actually is using 5G connectivity and multi-edge computing with video analytics is to spot the incident before it happens. So that's when you start looking at the behaviors of the drivers and start analyzing dangerous behaviors and stop an incident from happening. Then moving on to the customer space and sort of providing them information, there's a big push to understand how in-vehicle communication could work. So essentially moving towards an ambition of having naked roads by sort of 2050, where you may not need that much roadside furniture and infrastructure because you're able to communicate directly with the customer in their car. So the opportunities and sort of opportunities to grow and opportunities to be more efficient are massive for a business like Highways England. And they're looking at that. thinking about other public sector organizations, as Paul mentioned, loads of opportunities for cities as well. And we're seeing that cities are interested in understanding what 5G could do for them. So mobility and transport is always a big use case that everyone gets excited about, because there's a lot happening in that space already and it's easy to understand. Other use cases that we see people get really excited about is healthcare, especially when it comes to social care. Councils spend a large amount of their operational expenditure on social care, and being able to use video analytics in that kind of sort of scenario, again, could benefit not only the council in terms of, you know, the finances, but also our customers and citizens. So I think in sort of very quick summary, loads of exciting opportunities for growth because of this particular technology.
Thank you kindly. Wow, and it'll cure your asthma too. Well, but literally, in particular. Indeed, I know some great work going on with its application in social care, looking after vulnerables. Thanks very much indeed. And now, sort of a bit of a segue, because he's going to cover sort of some of the architectures and a sort of a ports example. Neil, could I introduce you, sir, and have your observations on the application spaces? And I think you do have some Port Authority digital twin exemplars up your sleeve.
Yeah, I mean, we've got a huge amount of work going on in service creation, and I think, you know, Dean on the Q&A is asking, you know, how relevant is MEC to new services, and I think it's a good question. I think there's elements of it that help us. There's elements that we've already got. There's new things that you know, we haven't even considered. Or we've given up because it was too hard. And I think there are, you know, bringing more compute closer to people will always help think, you know, will always help people be creative, and always allow you to try things that, you know, 20 years ago, an old fogey like me would have said, nah, you'll never make that work. Well, maybe now we will. So I think it's always good to experiment. But I think if we look at it from an operator point of view, you know, we're out there building connectivity all over the country, in fact, all over the world through BT Global. And the stark reality is that we need to do more than just connectivity. So we're working in healthcare. We're trialing a huge number of new healthcare services. It's all about, you know, through COVID, one of the things I think has really been spotlighted and probably needs to be even more work done on is the kind of elderly and infirm who are maybe home alone. And, you know, mobile edge compute helps us, or multi-axis compute helps us with managing the scale and the complexity of that. Is there any, you know, brilliant new discovery in that? Probably not, but the scalability of it and the reliability of it, for sure, it is helping us. A few other use cases that we're using 5G for, outside broadcast through BT Sport. You know, we've done a number of outside broadcasts using 5G, particularly through this COVID period where we've had our, you know, our commentators and our opinion people, what do they call it? There's a name for them, pundits, all over the place because of COVID, and 5G's helped us connect them and do some interesting things with video and virtual reality that would have been difficult. Again, edge compute plays a huge part of that. You know, we have a model of a, you know, a big 18-wheeler lorry with compute on the back that we drive to a stadium, plug in, and allow people in the stadium to do, you know, some fantastic things. COVID's put that on hold because we unfortunately can't get a lot of people into the stadium, but hopefully that's about to change. And then yeah, you talked about digital twins. So, and I think this is really important for the UK. And I think the stuff that Paul showed was super exciting from my point of view, which is how do, in a world where the UK is a knowledge economy, being able to build a digital twin for you to test things, program things, discover things, examine things in a way that's safe. You're not actually doing it in real time. You can use technologies like system dynamics to, perhaps create a flight simulator of a city or of a, a manufacturing plant, or as McLaren are down the road from where I live in Woking on their actual Formula One car. So, and then use the massive compute power that we've got in Edge to do some really quick processing that, yeah, you could argue do that in the cloud, but in some respects, if you're rotating a model, you want that, snappiness of reaction as you do it, an instant kind of response to the services, and then if you're building a product, you build a digital twin of a product, perhaps you've got a 3D printer at home, you can just press a button and print a prototype. And again, through COVID, lots of 3D printing done on stuff to help with face masks and other stuff that, had we had more edge compute, had we had more of this deployed already, would we have actually got even more? I'd like to think that we would have done. The other thing we're using, two other areas we're using edge compute for. One, believe it or not, and I have to say I was kind of surprised by this when my team came to tell me about it, which is we're using edge compute to really, and I think linked to what Hafsa was saying, to really plot routes much better than we've ever done before. Sure, we've got GPS, sure, we've got Waze, we all love it, but actually when you start to think about the number of journeys that happen every day that are almost predictable to like 90%, you put them into a big platform and say, okay, 90% of the traffic tomorrow we could predict. In that case, why don't we predict a space for them to travel effectively in? We have a pilot running with Ipswich Council in Suffolk around how we plan and rotate traffic through their city in a way that's super efficient and, takes a lot of congestion and all the negative stuff that goes with congestion out. And then finally, in ports and in manufacturing, and again, this is related to video, we've done a few use cases where, you've seen what happened in Suez and all the backlog of shipping containers, and in an increasingly in a world where the supply chain is increasingly easily disrupted, or there's so much demand that it's keeping supply chains moving is crucially important. Apart from the shipping time, the longest part of the journey for a product is off the ship onto a port and then into your hands. So we've done a huge amount of work where in Belfast, where we're able to help them get a lot more telemetry around what ships are where, what cargo's on them, what's the weight, what's the dimensions, where's the lorry coming to pick it up, and just bringing all those things together so that it's just a much more smoother process, and you can start to automate it. Now, there's a lot of health and safety concerns there because you drop one of these containers and it could be bad, but again, by building out a private network that Danny was talking about, we can really get to an incredible level of fidelity with sensors around what's where and how it affects. And then finally linked to that in manufacturing. So, the UK is a phenomenal engineering country. If you want something engineered well, you get on a plane, you come to London, you come to the UK and we build it for you. And I think 5G has got a phenomenal part to play on that, whereby if you are building something, you want assurance on that build. So imagine you put in, imagine that the factory of the future has a sphere of cameras where every step in the manufacturing process is recorded and certified automatically. So you're, Rolls-Royce and you're building an engine for an airplane, you want to know that was built right. And if you have a problem, you want to be able to deconstruct it so that you can improve it. Again, edge compute is allowing us to put that level of video capability in in a way that's scalable, so that as that engine comes together, or as that product comes together, you can see every single detail about it, and then go back and even do it serial number by serial number if you so desire, and really understand what went right, or where are there opportunities for improvement, or are we 100% sure this engine was built because we saw this weird telemetry. And again, linking the in-flight telemetry of the engine, where there's now millions of sensors, back to that production line, so that they can understand, what they could tweak, what they could change, what they could do better, is fantastic. And if you think about, again, food production, imagine expanding that into food production and farms and the kind of food production companies, and getting huge amounts of benefits and ultimately more efficiency. If we were as a global world, if we were able to improve our efficiency by 2 or 3%, that is massive. And each one of these little use cases that we're all talking about moves that dial. And we as telcos want to be a bigger part of that journey, because frankly, if we want to continue investing in the infrastructure, someone's got to pay for it. And right now, that's just on connectivity, we're going to run out of road on their ability to fund and build the infrastructure that these use cases need.
Thank you kindly, Neil. Yeah, some good observations in there.